All right. Thanks, everyone, for joining us today. My name is Romanas Sonkinas, and I work for a company based here in the UK called Hive as a technical lead/developer. And I will take this opportunity today to entertain you in various ways to show you how we've been building for the past few years the UK's largest IoT network. So, agenda. I'll talk a bit about what Honeycomb is and what Hive is and how not to confuse these two. I'll tell you a little bit about how Honeycomb works, how devices interact with Honeycomb, and we'll talk a little bit about various geeky things that you can find in Honeycomb and how we built the software in the first place. If we have time, we might do a very quick Q&A afterwards as well. So, Hive. Who of you are from the UK as a whole? Raise your hands. Excellent. Who of you have ever heard of Hive before? Okay, not the Hadoop thing. Less people. All right, so let me quickly tell you about Hive. Hive is the consumer brand made by British Gas here in the UK that offers you, at the moment, heating and hot water control. So let's really quickly glance over that, because that's not the super interesting thing in the world for us technical people, and we'll go into the more interesting things after that. So what you get is essentially inside of your house, we put a small device that's kind of like a Raspberry Pi, pretty much similarly spec'd. You can easily run Quake on it. It's all right if you can get to it. We also connect a small thingy to your boiler and then talks via Zigbee to the hub that we place inside of your home. And there's a small receiver inside of your living room that measures temperature, and you can use it as well to adjust things in there. At the moment, it only offers heating and hot water control. But hey, that would be kind of stupid to just leave it at that, and especially if we got so many kits connected even at the moment. So we want to be the thing that actually allows you to control everything inside of your house. So that's Hive, the consumer brand. That's what you go, if you go to an Apple store, you can find it. There's a nice kit in there. You can go and buy it, take it to your home. An installer from British Gas will come in and connect everything for you, and it will just work great. Honeycomb. Now, Honeycomb is actually the technology platform that is powering Hive. We are currently in 200,000 homes here in the UK, so a pretty decent amount of people connected. We got various folks, starting from technology enthusiasts, then to someone's grandma as well, who doesn't even know that she has Hive inside of your home, but maybe she has an iPhone given to her by your kids to control her heating. So in 200,000 homes at the moment. How all of this works. Most of the devices that you've got, smart devices nowadays, they don't necessarily talk internet. They don't talk IP. They don't talk TCP protocols. They usually talk something like Zigbee, Z-Wave, perhaps Bluetooth Low Energy, which is gaining market penetration as well. So you need some sort of a small gateway inside of your home that translates all of those low-powered radio protocols into something that you can talk to via the internet. So occasionally, devices can talk to Hive directly. If you have an internet-enabled device that you control the software on, you can control it. You can connect it to Hive, but in most cases, you have to have a hub inside of your home that translates all of that. A hub looks something like this. It's a small device, some chips inside, 2 antennas. This one only has a Zigbee one, but it's possible to have a Zigbee, a Z-Wave one as well. In some cases, a Bluetooth Low Energy one as well. Now, devices. There's thousands of devices out in the world. Philips Hue lights, hundreds and hundreds, if not thousands, of various different things that you can connect that are considered part of the IoT or connected homes spectrum. And the problem is that they all do things in various incoherent, completely different ways. So one light bulb by Philips is completely interface incompatible with another light bulb from another manufacturer. Sure, there's attempts in Zigbee, Z-Wave to standardize that, but as long as there's Zigbee and Z-Wave, there's always going to be some sort of differences in there. And then you have the whole swathe of IP-enabled devices that don't talk any of these low-level protocols that in some cases give you a RESTful API of sorts to interact with the device directly. That happens as well. So why the hell can't light bulb makers come up with standards for that? It's inconceivable. Now, I got this thing here, right? Someone might notice that is a ATI Radeon video card. Pretty good. It can run Quake 3 really, really well at a high frame rate. I'm actually not sure from which year this thing is, but believe me, it's not the most newest thing in the world, and its AGP as well, so quite old. And you've got that as well. And for the technology enthusiasts, you might notice it's a Raspberry Pi. So the size difference is quite comparable. And I'm pretty sure that when Quake 3 was developed by their developers, they didn't know about the Raspberry Pi. They didn't know that such a thing existed. Hence, but still, you can buy this and you can run Quake 3 on it. Amazing. How does that work? And the key to all of that is that there's a concept of a generic video card, a concept of how you can easily access video capabilities of that chip. And that's quite standardized. It doesn't matter, Quake doesn't have ifs in it saying that if it's a Raspberry Pi, do that, or if it's something else, do that. It just knows that there is a generic interface to talk to any video card. And that's great. That's amazing, isn't it? Now, we really want to do the same thing with the Internet of Things as well. And we've developed something called Canonical Forms. A canonical form is a schema. It's an interface that defines what is a light bulb. Usually a light bulb, you can control it, you can set it on or off. Perhaps you can adjust the brightness if it's a really amazing smart light bulb, or for super amazing ones, you can control the hue and similar things, don't you? So with Canonical Forms, you can actually have interoperability between devices, because you program something that accesses a light bulb, and you're pretty sure that it's going to work with any light bulb out there, as long as that light bulb has a correct driver and is connected to the Honeycomb or Hive platform, which is great. That solves a dramatic problem in the Internet of Things spectrum, doesn't it? Canonical form is something really simple. It's effectively a JSON schema. Here in this case, it's a schema for a very simple light device. It says a light can have state. It's either on, off, or unknown. In some cases, you can modify that state. You probably can't set it to unknown because, well, God knows, you might open a black hole or something. And you can adjust the brightness of it. That doesn't include hues and similar things in there at this moment, but it's easy for us to add all of that. So great. This defines what exactly a light bulb is. And we got JSON schemas for pretty much all devices that you can think of. Tens, if not hundreds of them. Great. Now, what Honeycomb allows you to do is that you can write the driver. And you write the driver in the most favorite language of all people inside of this room, I'm guessing, which is Java, which is great. It's my favorite language, too. And it's really simple. That's my kind of weird attempt at writing that driver just before the conference to show how easy it is. Obviously, the package has to begin with I/O because all cool companies nowadays have a domain that's in the I/O TLD. And it's really simple, really. You just have a little bit of boilerplate. It's Java. You have to have some boilerplate in there, don't you? That effectively says, hey, I'm a driver for a light bulb by my cool light bulb company. I'm a Zigbee device, which automatically pre-generates a lot of things for you so that you don't have to talk low-level Zigbee. And I'm saying that, I'm a device type Zigbee, and I'm stating as well my manufacturer. And that's a standard Zigbee attribute as well that effectively allows you to map that driver to your device, and the discovery becomes automatic inside of Honeycomb as well. It's quite cool, isn't it? You just write some Java code, you stick it on the hub potentially, and you have added support for a brand new device that anyone else now who wants to talk to a light bulb can just use your device. Great, isn't it? Now, if this, then something else. I can't say if this, then that. People get weird feelings about that. That's code too, really, isn't it, at the grand scheme of things. You write some Java code that says, in this case, it connects a motion sensor, and if it gets a motion detected event, it's not the best Java code in the world, but it works, believe me. Then you might attempt to control your thermostat and set the operating mode to heat and temperature to 31 degrees, and maybe you're simulating a smart thermostat of sorts in this case, which is quite nice. You can drop it into the hub as well. It runs in a sandboxed container, so you can't really use up all the memory or similar things. People are quite familiar with those concepts from Android. Nothing really new invented in there. So we really like to provide people with very, very easy ways of dropping their code into the platform and into the hub potentially, and that write custom code effectively that allows you to do various interesting things. So those were canonical forms and device drivers. We kind of really want to emphasize that it's easy for everyone to do so. You write some Java code, potentially some other JVM languages in the future, who knows, and you just drop it into the hub in an interface that I will talk about later. And stuff works. Hey, it's amazing, isn't it? Let's talk a little bit about some of the geeky stuff that's happening at Hive as well, because we don't have too much time. Hive is a big system, 200,000 homes connected to it. We're using a whole bunch of various interesting technologies in there that you can find people from in this conference as well. We got RabbitMQ. About 15,000 messages processed per second at the moment, and that's growing at quite a tremendous pace as well. Hazelcast, really lovely in-memory database, doing about 20,000 puts per second and growing too. And we got a really big Cassandra cluster in there with 9 terabytes of data. Well, you might think 9 terabytes isn't that much, but it's growing at about 50 gigabytes plus per day, which is kind of nice. And we've also got a pretty large Amazon bill at the end of the day. Believe me, that's a pretty large Amazon bill. But hey, Amazon provides you with loads of various interesting things that you can do. And this is the nice things about Honeycomb. What tools we use, what philosophy we got, what software we're using, some interesting buzzwords and locations. We're actually a completely UK-based company. We got an office here in London in the West End and an office in Cambridge as well for us. So you might think, okay, I'm talking too much, all of these exciting things in there. Well, when can I get my hands on any of this stuff? And that is a really, really good question. Well, not just yet. Bear with me. All of this is coming up in the relatively near-term future. We're hoping maybe within the next half a year or so. But we do offer an early access program for people who are really interested in all of this stuff. Now, you can come up to us. We're in booth B2, I think. That's next to Sonatype, who were here just previously, and between Couchbase as well. Now, if you come up to us and talk to us, you might just enter our Raffle, and you might even win this, which is a pretty nice device. It's an Apple Watch, pretty completely new. Some people like it, some people don't. But we quite like it. We quite like Apple devices. And if you want to win one of these, come and visit us in the booth. And who knows, you might be the lucky winner of that. And we'll obviously tell you a lot more about Hive, about what Honeycomb is, what you can do with it, and when you will be able to get your hands on the system, and when you can connect all your fancy Arduino-enabled devices to it that do these amazing things that you've discovered. And we got a couple of minutes left, so Q&A really. Any questions? Yes, please.
My neighbor has a Hive. How do I know I'm not switching on his feed?
So you don't generally steal other people's devices. That is managed at the Zigbee or Z-Wave level, which have concepts of acquisition mode or adoption mode, effectively. So unless you and your neighbor is installing Hive at the same time, that wouldn't be a problem. In 200,000 cases, we never had a thing where you steal a neighbor's device yet. Obviously, hey, that might happen, but who knows? Anything else?
You mentioned acquisition mode, so is there also a kind of concept of security? Obviously, as soon as you start enabling these things.
So as soon as you've acquired a device in your network, that's it, it's your device. It will refuse to talk to anything that's outside of the network, usually the gateway, which is the hub. So there's no possibility of someone coming in and sniffing traffic because Zigbee is encrypted as well. So I think security in-home is covered by Zigbee itself. Anything else? Sorry. Telemetry, really. You've got 200,000 hubs. They've got at least 2 devices each, so 500,000 devices reporting every couple of minutes. Usually they can report things as temperature, signal strength. We know a few things about that.
So everyone using Hive, you see what they're doing, you can build a picture.
We do. We have very interesting patterns when we've learned very interesting patterns in terms of how people control their heating, for example, when they're accessing the system. You wouldn't believe it, but one of the primary use cases for Hive is people get up in the morning and it's cold. So the first thing you do is reach for your phone, because that's usually next to your bed, and turn the heating on. And then you might just go to sleep for another half an hour before it kicks in. So we do have a data analytics department. All of the people that work with R, and they're called data scientists and etc. So all of that stuff is there too.
If you want to heat your room half hour before you wake up, your alarm clock should do this.
You can do that. Sorry, I'm afraid the time is up, so I can answer any other questions in the booth if you come up to us. But thank you very much, guys, for listening, and yeah, cheers.